On the review sheet?
I didn't see it. I haven't looked at the entire review sheet yet.
Yeah, let's look at the review sheet. Because it is on the review sheet. And remember, anything on the review sheet is fair game.
Let's go over it.
Okay? So, let's see, I have to read this carefully. Let's say I have the circle, x squared plus y squared equals 25, and I want to write the equation of the line tangent at the point -3, 4. Okay, so the situation is I have this is a circle, right? What do I know about that circle? It's centered at the origin and has a now I got the hiccups. A radius of 5. So there's my circle centered at the origin with a radius of 5, and there's the point -3, 4. And my job is to write the equation of that line right there. What does it take to write the equation of a line? Gotta have a slope and gotta have a point. Okay? I got the point. Now I need the slope of that red line. I cannot find the slope of that red line because I don't have enough points. Could I find the slope of this line? You know, I'm supposed to have that 24 hours in advance. Okay? I gotta have it by the end of the school day. All right? Because remember, it means work on my part, right? I gotta get organized, get a test to them and everything. So you need to help me out a little bit with that. All right? Now, can I find the slope of this line? This is a radius. And a radius and a tangent are always perpendicular at the point of tangency. Can I find the slope of this line? Yes, because I know it contains the point 0, 0 and -3, 4. So the slope of the radius, not the slope I want, but the slope of the radius would be 4 minus 0 over -3 minus 0 or -4/3.
Yep.
Which means the slope that I want, the red line, would be what?
3/4.
The opposite reciprocal of that, which would be 3/4. Now, your job is to write the equation of the line. So I don't care point slope, slope intercept. I'm a point sloper, so I'll use point slope. Y minus y equals x, or m times x minus x. So I end up with my answer being, let's see, 9/25 maybe? Let's do it the other way and see if I get the same answer. Y equals m x plus b. So 16/9/25. Yep, so I get the same answer both ways. That's the answer to your problem. Okay, super, thank you. All right. Anybody find?
Can you go over completing the square?
Yep. Okay, so we're good on this. Whoever asked this question, we're okay with this now? Okay. One more. We'll do a completing the square problem. Remember, when you complete the square, and you can complete the square on any problem, any quadratic, you can complete the square on. It works all the time. However, in order to complete the square, this has to be a 1. So in this problem, if I'm going to complete the square, the first thing I'm going to have to do is multiply everything by 3. If there had been a 2 there, I would divide everything by 2. If you're completing the square, that has to be a 1. So you do whatever you have to do to make it a 1. Now we move the 3 to the other side. To make room for this new number, we're going to add. And the number we're going to add, we find by doing what?
Halving 6.
Half of 6 is 3, squared is 9. This is a perfect square always. X minus 3. Then we square root both sides, being very careful to remember this side is plus or minus, so that we end up with 2 answers, 3 plus or minus root 6. Now, keeping in mind what we talked about before lunch, if I did the discriminant of this problem, which I didn't do, but if I did find the discriminant of this problem, would it be a perfect square or not? Wasn't it in this class we talked about that? Yeah. What did we say? If it's a perfect square, what is true of your answers? It won't have a radical. Did I have a radical?
Yes.
Therefore, do I have a perfect square discriminant? No. My discriminant is b squared minus 4ac. My discriminant is 24. It's not a perfect square. My problem isn't factorable. I got a wacky answer. I got a real answer, no i's, because why? The discriminant is a positive number. All right, anything else? All right, then let's go back to 1.1, pick up where we left off. I'd like you now, same page, so that's page 82 now. Page 82, just turn the page. And I'd like to look at number 20. All right, so here we go. We're looking at problem number 20 on page 82. A bakery sells a 9 by 13 cake for the same price as an 8-inch diameter round cake. So we go into the store and we can buy a 9 by 13 cake, or we can buy the 8-inch diameter cake. All right, and they sell them for the same price. The round cake is twice the height of the rectangular cake. So think of, you just bake a cake in a 9 by 13 pan and it's this tall. But this is a layer cake, so it's twice that tall. So just for simplicity's sake, I'm going to say this is 1 inch and this is 2 inches tall. If you don't like 1 and 2, you could make it 2 and 4. It doesn't make any difference. Which option gives the most cake for the money? Okay, these are the same price. So you go into the store and you have to decide, I need to buy one of these 2 cakes. Which one's going to be the better deal for me? How would we go about figuring that out? That's a real life problem. Dylan?
Find the volume of both.
Oh my gosh, find the volume of both, because that's how much cake you have, right? The volume of it. Now, this is a rectangle. It's like the Kleenex box. How do you find the volume of a rectangle? length times width times height. So that volume would be what, 117 cubic inches? All right. Uh-oh. Think of a layer cake. What shape is it? It is not a rectangular solid. What shape is it? It's a cylinder. This is a cylinder, right? Like a tube. Okay, how do you find the volume of a cylinder? There's a pi in it.
Pi r squared times height.
That's it. You cheating, Clark? Yes, you are, but that's all right. At least you had the initiative to look it up. Pi r squared times height. That's right. Remember, the volume of any sort of shape like that is the area of the base, pi r squared, circle, times the height. So for us, that's pi times, now be careful, r is 4, so that's 16 times 2. So that's 32 pi. All right, I need somebody to type that in on your calculator. What is 32 pi?
100.53.
Okay, so 100.53 cubic inches. So chances are this cake is prettier, but if you want to get more cake for your money, you're going to buy this one. Oh, that was so fun. Let's do another one. Let's do number 21. A garden shop sells 12 by 12 square stepping stones for the same price as 13-inch round stone. So we have like you pavers, you know, like you put outside in your yard or your garden or whatever. We have 12 by 12 squares, and we have 13-inch rounds. All the stepping stones are the same thickness. Which option gives the most rock for the money? Let's think about this for a minute. Let's think about this for a minute. Are we interested necessarily in volume in this problem? What are we more interested in than volume? What? Area. Yeah, how much ground can I cover? Because if these are paving stones, I want to cover as much ground as I can. So what's the area of that guy? 144 square, was it inches? I can't remember. Square inches? What's the area of this one? How do you find the area of a circle? Pi r squared, and r is 6.5. So let's type into our calculator 6.5 squared times pi.
132.73.
Therefore, if you're interested in covering the most area, you will choose squares. All right, let's see, what's next? Where's the paper? Number 40. Oh, this is good practice for our test too, because we're going to solve by graphing. This is a tough equation. It's doable, but I'd rather just graph it. So the absolute value of 3x minus 2 equals 2 root x plus 8. Now read the directions. They're asking you to do what I always ask you to do. Get your equation set equal to 0. Why do I want to get it set equal to 0? So when I graph it, I'll be looking for what? Where it equals 0, which is here, right? All right, so we talked about, well, in some class today I talked about it. Let's put this into our calculator. Now, I still have my stat plot turned on, and every time I graph, I'm gonna get those crazy dots. So the first thing I'm gonna do is go back into my stat plot and turn it off. I don't need those dots anymore. Then I can go ahead and put in this equation. Remember how to get absolute value. You press math, number, there it is, absolute value. Now I can't even remember how my window's set. I'm gonna go ahead and just hit graph. It's not good. My window, all I see is this little bit right here. I need to see more than that, so I'm going to change my window a little bit. There we go. Now I see a picture that looks like, oh, wait a minute. Looks like this. And I use the standard window. I went -10 to 10 on both X and Y. Alright, let's find these points. So, Griffin over, you guys find the first one. Jason over, you guys find the second one. We're finding this point right here. You guys are. Griffin's finding this one. What'd you get?
2.864.
This one's 2.864. All right, and Griffin, you got negative
1.086.
1.086. Anybody want to match those? Confirm that for me. Okay? So no matter what equation I throw at you tomorrow, when it says solve graphically, this is what you're doing, right? This is what you're doing, solve graphically. You're getting it set equal to 0 if it's not already, and you are graphing it and finding the zeros. Okay, that was simple. All right, 45. This is another one. I just thought we might need to practice with the negative exponents. So x plus 1 to the negative first. This is 45. And I'm just going to type it in. I'll adjust my window as necessary. You do need these parentheses though. Be sure you put those in. Oh, let me get it set equal to 0. Wow, this is kind of a weird looking thing. Did you get something that looks really weird?
Yes.
All right, I'm going to make a window adjustment. Let's change our x's to -3 and 3. Leave your y's alone for a minute, but change your x's, and let's see if that helps a little bit. It is wild, but let's talk about what's going on. You should have something that looks like this. Does it look something like that?
Yeah.
Okay, now here, I want to tell you, this is the axis, right here. This line that came in isn't really there. That line came in because as you watch the calculator graph, it did this, and then it had to get up here. So, I don't know about your calculator. My calculator can't pick up. Some of them do. But I'm seeing this line here, which is actually an asymptote. It's not part of the graph. It's a boundary for this curve and a boundary for this curve. This is really the same thing, but it's the axis itself, so we can move it in there. How many times does that cross the x-axis? That's the only answer to the problem. There's one answer to this problem. Let's find it. All the other stuff doesn't matter. Just set your left bound and right bound around the point you're looking for.
How do you get onto that?
Yeah, just you mean the cursor?
Yeah, like
Just
mine's
use
on
the
the
arrow
other
buttons.
one.
That's all right. Just move the arrow button to the left, and it'll eventually get over there. It'll follow the curve.
Negative 1.465.
I'll tell you in a second. Yep. Negative 1.465571. If we take a lot of decimal places. Easy. You guys got that. 51. All right, this will take us to the end of the period, probably. 51. The problem says, solve graphically, find all real solutions. Watch for hidden behavior. Okay, you don't even know what hidden behavior is. Let's go ahead and graph this thing. So I'm doing 51, and we're doing 51A. So we're going to put in 51A. Oops, it's 85. And plus this. Alright, I'm gonna make sure I take that in. Alright, I have my window still set the same as it was a moment ago. And I don't know about you, but I got something that comes up here and then something that comes down and does something like this. That's what mine looks like. I'm a little worried that's not big enough, so I'm going to go ahead and change my X minimum. Instead of going to -3, I'm going to back it up and go to -10. And I see the curve coming up and crossing right there. Do you? Alright, there is no question the curve crosses right there. So I'm going to go ahead and find that one right now. I do not know what's happening over here. That's a little confusing to me. I'll figure that out in a minute. But right now I'm going to find the zero that I know. So I'm going to second calc. And I'm going to put my cursor around that zero.
-3.
How do you guys do that so fast? You know what to do because you're just brilliant. Okay, that's awesome. I'm just now getting my bounds set. Okay, so I got -3. All right. Now, I'm going to go back to my picture. So I'm just going to hit graph so I have my picture back. And I don't exactly know what's going on here. I don't know if it's hitting or not hitting because I got a hash mark there and I just can't figure it out. So I think what I'm going to do is change my window. Now, I don't need to worry about this anymore, right? Because I already found that one. So I'm going to set my X minimum at 0 and see if that helps me at all. I just set my X min at 0. It touches all right. But you know what? Change your Y min to -0.1 and your Y max to 0.1. So -0.1 to 0.1 for the Y's. Wait a minute. Not only does it touch, but what does it do? let's change our x's. Change your x's to 1 and 2. And leave your y's at negative 0.1 and 0.1. What does it do? It touches it twice. It dips below. You couldn't tell it here, but it actually dips below. So how many zeros are you looking for? Well, 3 altogether, but 2 more. We already found the 1, but we have 2 more. This is called hidden behavior. And we're just throwing that idea out there to you so that you understand sometimes the graph is doing things that are hidden from you, depending on the size of the window you set. Now, what did I do with my y's? I made my y's really, really small, and that has the effect of magnifying the picture, because that says I'm looking from negative 0.1 to positive 0.1. I'm looking at a tiny little space, but I'm blowing it up so I can see more of the behavior. Can you do that on every problem you do? Yes. I don't think it's necessary to do that. I didn't do it here because there really was no question. The curve was going through, right? But this was a little bit strange behavior over here. I wasn't sure about it. So I blew my picture up so I could look at it more carefully. That's just a caution I have for you.
But would the difference between the x values there be like minuscule?
Oh, yeah, but they're 2 separate numbers.
Yeah.
Yeah, and your job is to find them both. I don't know what they are, but yeah, they're probably like point apart. 0.05 apart. So they're really close together, but they're still unique zeros. Yeah, different zeros. Okay? All right, folks, we finished 1-1. So listen to me, listen to me. We have finished 1-1. Tomorrow night, get on Schoology and look at the assignment, and you'll see the 1-1 problems. There's no reason why you can't get those done over the weekend. Okay? Yes. In fact, I have a minute. Let me hand out my sheets. I'll just hand them out now to you. These are the assignment sheets for chapter 1.
These are just the numbers we have to do. Oh, the math league's on the back.
Yeah.
What math league start? Oh, December 8th, 2000. They're
And we're in the laminated our signs, aren't we? It isn't no firm zone.
When do we put like set the pay for that?
Well, when I get the order forms, Chuck, I will pack them out and you will order a t-shirt and sign up. All right, you're free to go. I'll see you guys tomorrow. Because after all, we have class every day.